Hi folks, welcome back once again. Today I want to talk about roots and radicals, square root functions, and then nth roots. So get yourself something to write with because thinking and writing should always go together. And let's get started. Okay, so let's talk about the square root function. You remember this. You remember y is equal to x squared, right? It's a parabola, looks something like that. Brief review. What if we do the inverse function of this? Hopefully you've done inverse functions yet, but if not, it's not all that hard. An inverse function says we basically switch the x's and y values. Everything that's an input becomes an output. Every x becomes a y, every y becomes an x, that sort of thing. So if I switch the x and y values, I would get x is equal to y squared. And then if I square root both sides to solve it for y, I get y is equal to positive and negative the square root of x. But I can't have that as a function. Basically, that would give me like a sideways parabola here like this. But you know from functions that you can't have two different y values for the same x value. But we could if I went in here and just said, no, I don't want the negative. I just want the positive of it. So I don't want the bottom part. I just want the top part. Okay. So let's now build this function sort of from scratch. So that was just kind of to get us started. Now let's do this. Let's do f of x is equal to the square root of x. And just to be deliberate here, what we're doing is we're only taking the positive square root of x. So let me plot that now doing kind of a table of values. X and y, obviously 0 is a good place to start. So 0. What's the square root of 0? That's 0. That's not hard. That's the point right there, the origin. Okay. How about 1? What's the square root of 1? That would be 1. Oh, may all of our mathematics be so easy. That's that point right there. What about 2? What's the square root of 2? Not an integer. It's like 1.41, something like that. So let's do something now that maybe we haven't had a need to do before, but let's just use convenient values for x. I'll go ahead and leave this one here. This is approximately 1.4, not exactly, but approximately 1.4 or so, something like right in there. But what's something that we can take a square root of conveniently? Well, we can take a square root of 4, so let x be 4. What do you get? Square root of 4, 2. There we go. So now we come over here and I get that value. Is that 1, 2, 3? Yeah, okay, there we go. Starting to see it kind of fill in. How about 5? Well, 5's not convenient. So what's another number that we can take the square root of after 4? 9. If you let x is equal to 9, that gives us 3. Is that on my graph here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it is. 1, 2, 3. So we get this graph, that point right there. How about, oh, I'm kind of out of room. How about negative 1? Did the lights just flicker? Right, right as I said negative 1? That is unbelievable. This is like the best video lesson ever. We got a message from God that you can't take the square root of a negative 1. What's the square root of a negative 1? You can't take the square root of a negative 1? Not allowed. Does not exist. So there's a stopping point. I don't have any x's equal to negative 1 on this graph. The graph looks like a sideways parabola, but only the top part. That's great. We had a divine message that you can't take the square root of negative 1. That's fantastic. Actually, it's kind of stormy outside. I'm sure it was just coincidence. Oh man, my life is so great. Yours is too. All right, so it looks like that. I don't have the bottom part then of that parabola, just the top part. Okay, special points. Obviously, the first special point is the end. There's an end to this graph. I can go on to the right forever, but if I go to the left, there's a stopping point, the end. The end is where the radicand, which you should know is the thing underneath the square root, where the radicand is equal to 0. That's a very special point. The other special points would be the x and y intercepts, I and t, something like that. That's fine. But the end point really is the most special one. The domain. For the parent function right here, y is equal to the square root of x. That's where we start from. The domain would be x has to be greater than or equal to 0. Okay, so if I come over here to the graph, I'm allowed to have x values that are, you know, what was that, 9, and then 4, and then 1, and then 0, but I don't have any negative ones. Remember, this is the graph. The graph is the collection of all the solution points. This is just the grid space. This is not the graph. You might call it the graph paper, but that's the paper on which you draw your graph, and this is the graph. Okay, so x values have to be 0 or bigger. You can't go to the left. Also, the range, y values here also have to be greater than or equal to 0. I can have y's of 3. I can have y's in between. My y's can go smaller and smaller and smaller and smaller, but they can't go any lower than 0. I don't have any y values down here anywhere. There's no graph down here. Okay, so the y values are greater than 0. Now, general form. General form is going to introduce some things that we've done previously, but we're going to put them now together with square roots. So general form would be f of x, or y, is equal to a square root of x minus h, and then outside of the square root, so maybe a little hook on the end to show that it's done, plus k. All right. Now, just like from a parabola, h has got to do with a shift left or right. K is a shift up or down. And a is a stretch, and if it's positive or negative, if it's negative, it's going to be a flip. So the principles are the same that you would see with a parabola, except now they're applied to this new shape. So let me do an alternate one. Let me do another one here that, say like in red, I'll do y is equal to, what was the one I was going to do? I'll do y is equal to 2 times the square root of x plus 5 minus 3. And the square root ends like right there. Okay? All right, so the most important point we need to find is the end. The end is where the radicand, and remember the radicand is right here, where the radicand is equal to 0. So if I do x plus 5 is equal to 0, I get a value of x equals negative 5. That's the end of the train, so to speak, or the beginning of it, if you want to think about always going to the right. If it's set up this way. So now let me just do a table of values and we'll run that through. So let's do x and y. When x is negative 5, what's y? Well, y, if I plug it back in down here now, y is going to be then 2 times the square root of negative 5 plus 5 and then minus 3. So come on with the math now. That's going to be like 0, right? Square root of 0 is 0. 2 times 0 is 0. And then this y value then is going to be negative 3. So the y value is then negative 3. And so now if I plot that point, negative 5, negative 3 will be left 1, 2, 3, 4, 5 down, 1, 2, 3, right here. Okay, so that's the new starting location. If you wanted to do something crazy, you could say negative 6. And I would say then, well, what's 2 times the square root of negative 6 plus 5 and then minus 3? What's negative 6 plus 5? Negative 1. What's the square root of negative 1? Not real. So this point here does not exist. The graph is going to somehow start here and then go to the right somehow. Okay, probably with that shape like that, but you know, where exactly is it going to go up really high? Is it going to maybe go down low like that if it's a negative, it's been flipped over. So I'm going to use values now greater than -5. And if you really want to get into it here, let's do this. The radicand has to be equal to or greater than 0. So that corresponds with greater than or equal to -5. So then let's do -4. So what is now, it's going to be 2 times -4 plus 5 minus 3. -4 plus 5, positive 1. Square root of positive 1 is 1 times 2 is 2. 2 minus 3, -1. So -4, -1, that location right there. All right, now I can maybe do -3, but that's not going to give me a number that I can easily take the square root of. What can I easily take the square root of besides 1? Well, how about 4? So my thought is now, what does x have to be to make this entire thing equal to 4, the radicand equal to 4? If x is -1, the radicand would be positive 4. So -1. So 2 times the square root of -1 plus 5 minus 3. So -1 plus 5 is 4. The square root of 4 is 2 times the 2 that's there, that's 4, minus 3, positive 1. So -1, positive 1 is that location right there. And maybe I'll do one more. What else could I take the square root of? 9? If I did the square root of 9, that would mean here that my x had to be, did I do that on my example? Yeah, it would be 4. 4 plus 5 is 9, and then I can take the square root of 9. So let me do an x value of 4, which gives me the square root of 9. Square root of 9 is 3, times the 2, which would be 6. 6 minus 3, 3. So I'm plotting then all of these points here. 1, 2, 3, 4, up 1, 2, 3 is that location right there. So now I'm smooth curve starting up and going this way. And it's a bit wider of a parabola, but you get that there. Okay, so I get that one. Let's do the domain. The domain. X values have to be greater than or equal to, guess what? -5. We had that from right here. Okay, now the range. What's the lowest y value? Because there's a low point to the y value and then it goes up from there. Lowest y value, -3. So y has to be greater than or equal to -3. And there we go. Nifty, huh? So with those h's and k's, you can shift that thing around. And with the a, since our a here is 2, it stretched it up a little bit. If it was less than 1 but still greater than 0, it would be a squishing down. And then if it was negative, it would flip it over. Okay. If it was negative, it would maybe look something like this, where it would start here and it would go down and it would go that way. But in any case, key concept. The key concept here is to find set the radicand greater than or equal to 0 first. Okay, that's the key idea. Find the ending point. Okay, so I will let you do now the exercises then. Here's one that's just a reflection. Here's one that's just a vertical shift, and then here's one that's just a horizontal shift. I'll let you work on those. Just plot some points, plot some reasonable points. You should be able to work it out. And then combine practice. All right, so let me do this one now. Let me do the combined practice on number 1. Here I've got H and K and an A. So let's focus in here and let me see what I got. First of all, I need to set the radicand, x minus 4. X minus 4 greater than or equal to 0. So that means x then is greater than or equal to positive 4. So I'm going to pick some values now for x. X and y. So if I do x is 4, follow the math now. 4 minus 4 is 0. The square root of 0 is 0. 3 times 0 is 0 plus 2. Okay, 4, 2. Right there. Now, what's the next thing that I can take the square root of easily? Well, I can take the square root of 1. What does x have to be to make my radicand 1? 5. So if I plug 5 in here, 5 minus 4 is 1. Square root of 1 is 1. 3 times 1 is 3, plus 2, 6. Oops, over too far. So 5. No, hang on. 3 plus 2, 5. It jumped and I lost my mind. Maybe I'm having some electrical shortings going on, like the lights. Oh boy, maybe. Wow, that's really kind of stretched and I'm kind of off. The next value, just for giggles, let's see, we could take the square root of a 4 next. What do I have to make x be so that I get, that would be an 8. I think if I let x be 8, then that's 8 minus 4, which is 4. Square root of 4 is 2 times 3, which is 6 plus 2. That would be then 8 in here. So it would be off the graph. So it looks like this. It comes up very smooth and then goes like that. Kind of out of room on that one. Okay, but notice it's been shifted to the right 4 units. It's been shifted up 2 and it's been stretched. How do we know that? Well, okay. It's been shifted. Remember, this is an H, but it's shifted the opposite sign that you see. If you see a negative 4, it doesn't mean left 4, it means right 4, because you go by the opposite sign. So shifted right 4 units, so the original vertex or the original beginning point was there. It's been shifted right 4, and then it's gone up 2, so it's gone up 2 from there, and then it's been stretched. So all the y values get bigger quicker. All right, I will let you try number 2 on your own. Okay, graphing cube root functions, not square root, but cube root. Okay, so let's talk briefly, because I'm not sure exactly where you're coming from. Let's talk briefly just about the graph of y is equal to x cubed. Now this is not really part of the lesson, so just kind of watch this rather than writing it on your paper if you're doing it on your note sheet that I provided for you. If I do a table of values here, I'm going to get x and y. Let's do 0. Cube of 0, 0. So it's going to be the origin down here. If I do 1, x cubed or 1 cubed is 1. So that's going to be 1 here. If I do 2, 2 cubed now is 8. So when it's 2, 1, 2, 3, 4, 5, 6, 7, 8. It's way up here. Now ordinarily, if I had a parabola, it would go up on the right and it would go up on the left. And notice how steep this is. But it doesn't work that way for a cube, because a cube, when you cube something, if the base is negative, you keep the negative, right? Because you have an odd number of negatives. Odd exponents maintain negative bases. So if I said now negative 1, what is negative 1 quantity cubed? That's negative 1, because a negative times a negative times a negative is still a negative. So instead of going up to the left, I would then go down. And if I said negative 2, that would be negative 8. So negative 8, wait. 1, 2, 3, 4, 5, 6, 7, 8, way down here. And so if I get in here close, and you can see, it's a smooth curve that starts low and goes up. And it goes up very, very rapidly. Across there, and continues to go up. But on the other side, it comes around and goes down. So there's like a little twisting that goes on in there. It comes down and then a little maybe flat for just an instant and then down again like that. It doesn't come straight through. It comes down, curves, and goes around. Now, when you get into higher level mathematics, you'll talk about concave up and concave down, and those are crucial concerns. They're good. They're good concerns. But this one changes concavity when you switch. That's cubed. But we're not doing that. We're doing cube root. Well, cube root is just the inverse function of that, right? If I were to do the inverse function, and I'm just going to work this way, I would switch my x's and y's. So then x is equal to y cubed. Well, how do I solve that for y then? Well, you would undo the cube by cube rooting the left and cube rooting the right. And so then I get this right here. Okay, the parent graph. Y is equal to the cube root of x. And let's do some table of values now, and I'll do this one in blue. X and y. Again, let's pick values of x that are convenient. Can I take the cube root of 0? Sure. What is the cube root of 0? 0. How about when x is 1? What is the cube root of 1? Also 1. Now don't do 2. The cube root of 2, just like the square root of 2, is not a integer. Okay, it's a smaller decimal. What's the next biggest number that I can cube root? Well, you need to know your perfect cubes. 1 cubed is 1. What's 2 cubed? 2 times 2 times 2. 8. So when x is 8, what is the cube root of 8? That's 2. Because 2 times 2 times 2 is 8. Okay, now what about negative 1? Oh, you can't cube root a negative 1, Mr. Marsh. Absolutely not. Wrong. Sure you can. You can cube root a negative 1. This is asking you what cubed is equal to negative 1. Well, negative 1. How about negative 8? You can't cube root a negative 8, Mr. Marsh. Wrong. This is asking you what cubed is equal to negative 8. Negative 2. So if I were to plot these points now, it would look like this. It would be 0, 0, 1, 1, but then when x is 8, y is 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. This point right there. And then it would be negative 1, but then negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 right here. And do you see maybe the got spun? It got kind of like turned around, comes up and goes this way. Now, through. And then it comes down and then curves to the left. So again, there's a twisting that goes on with this. Comes through and then comes down through here like that. Okay, so in red we had the cube function, but I really don't want that. And so now in blue we have the cube root function. It looks like an S, so to speak, but it never really makes a curl in the middle. It comes to the left and then comes down and then to the left again. Or better yet, start from the left. It goes up, it goes to the right, and then up, and then a twist, and then to the right some more. Okay? Now, this same thing here, graph this one. And I want you to graph this one if you're doing the exercise for me. I want you to graph this one on the same coordinate axis because I want you to see the shifting that goes on in here. This is the same thing as y is equal to a times the cube root of x minus h plus k. H and k still mean a shift left and a shift right, and then the a there is a stretching. So plot some values there. Be smart about the values that you pick for x. You want to find one. Values of x that allow you to take the cube root of x plus 3 easily. And then I will leave that as an exercise for you. Okay, so for this one, the distance an object falls when released from rest is given by d is equal to 16t squared. Here's the formula, where d is the distance in feet. Solve the formula for t. Okay, so distance is equal to 16t squared. The first thing I should do is I should divide everything through by 16. So divide by 16, divide by 16. This cancels. D divided by 16 is equal to t squared. Now how do I undo the square? Because I can't undo the square exponent until I get everything else but the exponent moved to the left. How do I undo t squared? Square root the left and square root the right. And so then I get t is equal to the square root of d over 16. Isn't that equal to the square root of d then just over 4? And we're talking time here, so that we're talking the positive of it, so be careful on that. Maybe there's a negative of it. If you guys are in physics class and you've done this, is there a negative answer to that? Because, you know, physics is where you kind of put the stuff together and it means something now. Okay, now on to the next thing. Let's do some roots other than squared and so forth. So follow me along on this. If I do exponent form on the left, 5 squared, 25. 5 cubed, wasn't that 5 times 5 times 5, right? Because the base is 5. That would be 125. 5 to the fourth, 625, okay? So in these situations, I am going from the left to the right. But now let me reverse it. How do I undo a cube? Well, I would then do a cube root, okay? So isn't the cube root of 125 equal to 5? Yes, when I go to the right here. What is this one? The square root of 25 is equal to 5. That's radical form, by the way. This is all radical. Radical is this symbol right there. Radical form. By the way, what's the number that sits right up in here? What do you mean, Mr. Marshall? I said this was the cube root. This one's the fourth root because it undoes 5 to the fourth. It takes the result and goes backwards with it to give me my original result. What's the number that goes right there? The number that goes right there is a 2, although you don't write it. It's kind of silly to write a 2 right there because everybody understands that if it's blank, it means 2. There's never going to be a 1. There's never a 1th root of anything like that. You don't. It's not even a thing. It's not a thing because it's unnecessary. It's meaningless. It's like, well, I guess it does have a meaning. It's just, it does nothing for you. It's like, hey, let's multiply it by 1. Okay, nice. Like, what's that do for you? Nothing. So when you have a root with nothing written up in that little crook, it means a square root. But if you don't mean a square root, if you mean some other kind of a root, like a cube root or a fourth root, you have to write the number there. So what does that mean? So here's what it means. It means that 5 is the square root of 25. And you knew that. We might actually call this the second root. And from this situation right here, we can say that 5 is the cube root of 125. And you probably knew that one. We might even call this the third root. But 5 then for this one is the what? This one's just the fourth. The fourth root of 625. There's no special shape name after that. And why is an exponent of 2 called a square? What's that got to do with the geometric shape of a square? Why is the third exponent, an exponent of 3, why is that called a cube? What's it got to do with the shape of a cube? You think about that. And then why is there nothing for fourth? You think about that. Okay, so now here's the general principle. If I said that a raised to the nth exponent is equal to b, then to reverse the process, I would say this. If I take b now as my radicand and I do the nth root of it, that's equal to a. Okay, so for example now, if I do 5 cubed as 125, how do I reverse it? The 125 goes here, and this would be the cube right there, and the answer then is going to be 5. Okay, so the cube root reverses the process that the cube exponent originally did. Okay, so now let's talk about some terms. First of all, the thing that's the n, the thing that tells you what kind of a root it is, that's an index. The thing that is underneath the radical symbol is called the radicand with a D on the end, not a radicant with a T. It's D as in delta. Okay, and then this symbol right here is the radical. So now, how would you simplify the following radicals? And now we have roots other than a square root. So let's just take a look at, let's say this one, fourth root of 81. This question is really asking us, what to the fourth is equal to 81? Go backwards. What to the fourth is 81? You should recognize that. If you need to maybe get out your calculator and do things that are repeatedly multiplied to give you 81, that's what that means, right? The fourth here means things that are multiplied. So it's going to be, maybe an x times an x times an x times an x. There's 4 of them. What does that equal to be 81? Well, 3. Okay, so the fourth root of 81 is 3. You should know what that means and be able to do that on your own without having to use a calculator to do that. Okay, that should be something that's within easy reach for you. even if you have to do a little bit of a process to get to it. All right, so now what is the cube root of a negative 8? Can you take a cube root of a negative number? I think we already talked about that. Okay, now this one, cube root of negative 1,000. Well, you can take a cube root of a negative, so the answer there is going to be a negative. And now what multiplied by itself with 3 of them give you 1,000? Should be negative 10. Okay, why is that true? Because do the opposite process. Negative 10 cubed, is that negative 1,000? Yes, it is. And so what we're kind of looking for here is we're looking for the base that when you cube it gives you negative 1,000. All right? I've kind of been doing this sans notes. Let me go back to see what I got. All right, so let's now do, the rest of those I'll leave for you to do on your own. Let's do this one now. Simplify the following radicals with variables. Okay, so your eye has to come over here and find the cube. It's a cube root. All right, so we're looking for groups of 3. And do it just a piece at a time. Can you take the cube root of a negative? Sure you can. So the answer is going to be negative, and then I'm done with that. What's the cube root of 27? You should know that now is 3. Good, done with that. Okay. What is the cube root of y to the 12th? Well, what does that mean? Can't I say that that's the cube root of something cubed? If I can figure out how to write y to the 12th as something cubed, then this cube root will cancel this cube, and I'll just have what's in the parentheses left over. How do I write y to the 12th as something cubed? You should be able to see that it's going to be y to the 4th. Because when I raise an exponent to an exponent, I multiply them. So 4 times 3, that should be 12. There we go. So now what'll happen is this, with all of them, but with this one, that the cube root will annihilate the cube, and all I have left is that, y to the 4th. There's your answer right there. If you're not sure, just cube it. Take negative 3y to the 4th quantity cubed and see if you get negative 27y to the 12th. Okay, so the numbers are probably a little easy. The variables might seem hard to you now at this point, and sooner or later that will switch, and pretty soon you'll be able to see a pattern, and then the variables will be the easy things. Oh, this is real simple. It'll be the numbers that maybe give you a little bit of grief. Okay, let's talk about a special case now. A special case is when you have an even index, like an even number index leaving an odd exponent. So let's look at this one, the square root of 9x squared y to the 4th. What is the index? What is the root that I'm taking? It's not written, so it's a square root. Okay, because of the properties of radicals, I can really say that this is the square root of 9 multiplied by the square root of x squared multiplied by the square root of y to the 4th. Because it's multiplied here, times, 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 I can make them individual square roots, and now I can simplify them individually. What's the square root of 9? That's easy, that's 3. Done with that one. What's the square root of x squared? Well, that's easy, that's going to be an x, so now I'm done with that one. What's the square root of y to the 4th? Isn't that equal to the square root of y squared squared? Yes. So when these eliminate and I'm left with just that, it's going to be y squared. There we go. Almost. There's a potential problem here. If I let x or y be a negative number, I might have an issue. What do you mean? Well, if I let y equal negative 3, what's y squared? Positive 9, right? Can I take the square root of something here and wind up with this value here being negative? No, it's always going to be positive. So there's no problem with the y. If you're not sure what I just said, how can the answer to a square root problem be positive? Because if y is negative 3 here, it gives me a positive 9. That's not a problem, okay? The problem is this. how do I take the square root of something and have the answer be a negative? Because what if I let x equals -3? What if x was actually equal to -3? Essentially what I'm doing is I'm saying the square root of x squared is equal to a -3 because it's, they cancel. This is not allowed. You can't take the square root of something and wind up with a negative answer, because it wasn't negative in here, wasn't it? Wasn't this a positive something? If I take -3 and I square it, isn't it going to be a positive under the radical? Yeah. But when you take it out, it can't wind up in the end being a negative answer. So here's how you would adjust that. You would have to do an absolute value bar around the x. Okay, so to wrap it all up here, here's what's going on. When you do an even index, like a 2, and your result gives you an odd exponent, what's the exponent on the x right there? 1. And that's an odd number. You have to do absolute value bars then around the thing with the odd exponent. You don't have to do it with this one here, because even if y itself was negative, when you square it, the answer to the square root is positive, and that's okay. All right, here's one for practice. I'll leave you to do that one on your own. Now let's simplify a couple of these. Here we go. Let's do the first one. Okay, square root of 9x to the 10th. Really, this is now the square root of 9 times the square root of x to the 10th. Okay, so that's going to be 3. Hopefully you see that the 9 comes out as a 3 really easily. What's the index? A 2. What do I get when I do the square root of x to the 10th? Well, how do I write that? It's going to be the square root of something squared. Wouldn't this be x to the 5th? Right? So then that's going to be 3x to the 5th. But like I just said, you did an even index with an odd exponent as a result. You need absolute value bars around there. There you go. Just to make sure that it can't ever be negative. Okay. Do you see a pattern between 10 and 2 and 5? You think about that. Let's see now. Let me do this one right here. Okay, this one looks hard. It's not actually. This one's really kind of easy. Notice the negative. Oh no, it's a negative. Wait a second, it's outside the square root. If it's outside the square root, you're not taking the square root of a negative. It's just the negative, and then after that, then you do the square root of the thing. And what's the base? The base is just q cubed plus 5. That's that group raised to the 4th. So my question is going to be, it's the negative of the square root of, how do I write that as something squared? It would be the inside of q plus 5 squared. Can you see my layering that's going on in there? So the negative carries along because it's outside the radical. And when I do the radical stuff, this radical right here annihilates this squared right there, and all I'm left with then is the base that remains, negative of q plus 5 squared. And maybe that's as far as I need to take that one. Not a problem. How do I wind up getting a 2 right here when I did a 2 index of a 4 right there? You think about that. Let's do this one right here. Okay. One thing at a time. Here I got a single radicand, all right. I notice I got a negative sign out front again, and since this one's odd, it would actually be okay if I had a negative inside there, but I don't. I'm just pointing that out. Okay. So the negative carries along. I need to do the 5th root of 243. What multiplied by itself when I have 5 of them gives me a 243? Let's see here. 3 times 3 times 3. I'll do it like that. 3. Where's my? There, I forget what I'm doing. 3 to the 5th. 243. It's 3. So this comes out as a 3. Okay. A to the 10th. The 5th root of that. A squared. B to the 15th, b cubed. Now, do I need to put absolute value bars around any of this? No. Because if I have a odd index, I don't need to worry about avoiding a negative answer. Because an answer can be negative. That's fine. Okay. So I think that about wraps it up. Let's see here. Here we go. Should be back to me. Let's see here. Square root functions. Find the place where your radicand is greater than or equal to 0. That's going to be kind of your starting point. What else now? When you do roots, pay attention to the index. The index is the number written in the little crook. And then you're looking for the base that then when you simplify gives you that exponential answer. That didn't come out very good. I think you got the right idea though. Okay. May your days be merry and bright, and may all your mathematics be right.